without any waste of time, then I would like to introduce our presenter in this particular room, room 2. Welcome, everyone. Our presenter is Professor W. Olivier from the Nelson Mandela University. See, I live in Nelspruit. Now I'm saying Nelspruit, but it's Nelson Mandela University. And he will be presenting to us on the topic of GeoGebra Classroom for post-COVID mathematics learner support over distance. Welcome, Prof. The floor is yours. Thank you very much.
Thank you very much, Raja, for the warm introduction. And from my side, welcome to all the workshop participants. It is a very exciting opportunity for me to share with this conference some wonderful work, wonderful things that have already been shared, and I look forward to also participating in the next day or two. The GMMDC, or the Governor-Mbeki Mass Development Center, of which I'm the director, is an engagement entity in the science faculty of the Nelson Mandela University, and we focus on customized teaching and learning models. We call it the techno-blended model for maths and science, and we use various innovative apps and digital resources, mostly linked to the curriculum, but focused on professional development of teachers, mostly at the secondary schools, and the incubation of learners. And we have more than 10 years of intense development experience, where we try to be innovative in the context of trying to face and contribute to address some of the challenges in education. And 2-3 years ago, we have adopted the STEAM approach. If I can just share my screen as well to have my presentation parallel to what I'm saying. So we have also adopted GeoGebra as part of our approach. And this is what this workshop is all about, to show a very specialized and we believe innovative approach to utilizing GeoGebra applets on phones to support the teaching and learning of mathematics. But it can also be much broader than that for science and also for STEAM education. So yeah, the whole appletological, if I may call it that, approach to using customized GeoGebra applets, because GeoGebra applets exist out there as an open source resource, but not necessarily designed specifically for a small phone screen. And this is where I think the innovation lies, and hopefully through our interaction and the activities of this workshop, we can demonstrate that there's great potential in using GeoGebra in this particular way. So for those not too familiar with GeoGebra, allow me 1 or 2 minutes just to introduce this fantastic open source software that has been around since 2008. And it really supports the teaching and learning of mathematics and science across various grades from primary school, but predominantly in the secondary schools. And it's been used by, in fact, millions of teachers and learners worldwide. It has many different versions of the GeoGebra application for various scenarios, and we're not going to go into that now. And it has a well-established global community of practice. Our guest speaker this morning also referred to GeoGebra. Christopher Navesi is a good friend and a collaborator of our center. So, many special communities make use of this locally and also internationally. Locally, we have an institute for GeoGebra at the Nelson Mandela University as well. And the wonderful thing about this is it can be utilized offline and online. The whole idea of hybrid approach to utilizing technology in education is becoming very important, and it can be used across many operating systems with many device types. So there's wonderful, broad platform and access to use this software in different ways, particularly for the teaching and learning of mathematics. It also has classroom resources, which can be downloadable offline to use this for particular educational purposes. That's just a little bit of background about GeoGebra. How are we going to use it in this workshop? So allow me 1 or 2 slides, and then we're getting into the activities where I hope that you will actively, interactively, and synchronously, participate with these demonstrations of the applets via mobile phones. And I hope you have your mobile phone ready as a second device, because this is the exciting thing that we're going to do in this workshop. I will facilitate, GeoGebra in the context of mathematics and mathematical problem solving. And at the same time, you can interactively, follow and use the applet on your phone as well. And I'll say quite a bit more about that just to prepare for the workshop activities to follow. So online GeoGebra applets, because it has to be utilized online, can be accessed anywhere, anytime. This is exciting. It can be used synchronously and asynchronously, and I'll explain a little bit about that. Today we'll use it synchronously, in other words, at the same time. And I will play the role of the teacher or the facilitator, and you can then think for yourself, if you were the learner anywhere, any place in the world, synchronously, to be able to participate using your cell phone. It will be fantastic. And we use for sharing widely via social media and otherwise, even by hard copy. We use QR codes and URL links. The URL is a link directly to the applet online on the GeoGebra platform as it is. And the QR codes is a very flexible way to really access the applet by just scanning with your phone or any other device that has a scanner to access the applet directly and to synchronously as well. These customized GeoGebra applets, and these are customized because they were specifically developed and designed. And the design started at the beginning of the year as an innovative way to utilize mobile phones. So the small phone screen, we use special functions and affordabilities to really make it, viable and exciting for teachers from a pedagogical point of view, but also for learners, which can use it anywhere, anytime for the interaction and learning of mathematics specifically. So what I'm saying for mathematics today is also to some extent true for science, many different areas of science, but we'll focus on mathematics. So this really brings very much innovative opportunities for new teaching pedagogies, including also to engage with STEAM activities in a synchronous way using, phones and GeoGebra applets. It really focused on interactive visual learner support over distance, and the over distance thing is critically important, specifically during COVID and even in post-COVID times in South Africa. It has a broad access, for learners from under-resourced schools, and that is what our center at Nelson Mandela University focused on specifically, to try to get innovative models to really get access broadly. It is very cost effective. As I mentioned, the software is open source. You don't even have to download any software for that matter to be able to use applets. And the cost of utilizing these applets online is extremely low. It's in the kilobytes, not megabytes range. So with data cost being a very key challenge in education, I think this also brings a new possibility to effectively and efficiently utilize technology in this way. And of course, it has great value, we believe, for post-COVID challenges in education. And particularly for today's conference, it has a much broader value base, but it can also be utilized for preparation for learners for problem-solving competitions or science competitions for that matter. So please keep that in mind, because this is the theme of our conference. So let me then invite you to start off with, if you have your phone ready by your side and you have an internet connection, because that's important. How do we prepare our phones? It's very simple. It's a few steps, and my presentation will be shared as well, so you can revisit that afterwards. To gain maximum value from, these, which we refer to as GeoGebra for Innovative Practice 4IR sessions. So that's a broad theme that we have for the STEAM project linked to GeoGebra at our center. And we use hyperlinks and QR codes. And at this stage, I will also very soon share the URL hyperlinks in the chat so that you can directly, if you have a laptop and you don't have a phone, you can even participate, synchronously in a very much smooth way using your laptop, because I'm using the same applets and I'm just accessing it using my laptop and the Zoom platform at the moment. So with the phone in hand, you can access the applets that we're going to be interactively work with together soon using the link. Very easy. You just touch the link on your phone or you click on the link. And there are a number of steps that are critically important to have the maximum value for utilizing GeoGebra applets over distance with phones. First of all, we have to have an internet link. That goes without saying. Hyperlink, you have to select hyperlink because we use the link way of accessing. There are two ways. You have to rotate your phone to landscape mode because that is when the biggest possible area for the phone screen is available then for demonstration and for interactive, engagement with the applet. You have to also put your GeoGebra applet in full screen demo mode. And I will just tell you what that means. Whenever you have accessed the applet via clicking or touching the link or otherwise, you will see a small little icon at the bottom right-hand corner of the GeoGebra applet screen. You have to touch that to make it into presentation mode. It's very much like putting PowerPoint in presentation mode. And then you're ready, and then the action can start. Let me just repeat this, exactly the same as before, but we can also use QR codes. And at the center, I've started a whole series of these applets, capsule-lined, problem-solving type, and many others, which I'll say a little bit more at the end. But you can access these via QR codes as well. In other words, you can scan with your phone. If you can scan any QR code with your QR reader, must be installed, then you can do the same, and you can access the applet in exactly the same way as before. And I'm not going to repeat these steps to allow you then to access and interact with the applet at anywhere, anytime. But today, we would really like you to try this and access and interact, as I will explain, just to follow the steps for a few of the applets that I've prepared to demonstrate the different mathematical problem solving and other demonstrations that are possible. Again, don't forget to touch this little button at the bottom right-hand corner. Just to summarize, or before I get to that, I have also for your benefit, list a 3 open source free QR scanners. If your phone does not have a QR scanner, I would recommend Google Lens. Most people use that anyway. So if you just take your Google Lens app, activate it, point it to the QR code, you will be taken directly to the applet, and I'll demonstrate exactly what that looks like before we get into the activities. Any one of these, and I've just included the QR codes if you want to just pick it from the screen, because this is how you will access, or how you can access now while listening to my presentation via Zoom. You can access any QR code by just pointing your phone to the QR code, and then we can take it from there. Excuse me. Just note that your phone camera, most smartphone cameras has a built-in QR code reader anyway, so you can even use that as well. So that is just in preparation. So just to summarize, how does it work? You have a QR code or a link that you touch, and then you will see that you'll be taken to a link, which is the GeoGebra online link to the particular applet that will be considered or must be demonstrated or must be shared for that matter. It will take you to the applet itself in GeoGebra mode, but in portrait format. And this is important. So you must allow your phone to be auto-rotated in terms of the pictures on the screen. Most of us have that function and know how to do it. So please allow you to rotate to landscape format, because these applets are all designed to be demonstrated and interacted with in various ways using a phone in this way the screen is in landscape mode as well. Then, it's very important to be able to see this little button at the bottom right-hand corner, and hopefully all of you can see. Very small, unfortunately. You have to scroll up so that the applet, this becomes visible. It's not necessarily visible to start out with. You can only scroll these GeoGebra applets by dragging across this GeoGebra bar, as I illustrate on the screen. And then you must touch or click maybe a number of times until this particular button then becomes enlarged, which show that this applet is now in demonstration mode and ready to be interacted with in various ways, as I will demonstrate it. So touching this button, putting it in demonstration mode, then we're ready. So hopefully that makes sense, and hopefully you will be able to test it now. Afterwards, clearly you touch this button again and exit as you normally exit from any app on your phone. Let me just say again, you can even do this via your laptop if you want to. And at this stage, I will try to just share in the chat the links that are linked to the 4 activities. I will do it one by one and discuss it as well. If I can just see if I can share this, if I may just go out of the presentation mode at the moment.
Done for activity 1.
I don't know, Arnold, if you're in a meeting, my colleague Arnold Waze is working very closely with me with these applets. Can you please share?
Yes, I've done for activity 1.
Done. Fantastic, fantastic. So this is the first activity. This is more general. And this is also a very valuable applet to share with all learners out there and everybody that is interested in problem solving, whether it's scientific, but mostly mathematics problems. Here we have the QR code. So participants, you are invited now to scan this code to get direct access to this particular applet. I will do so as well, but I will go through the URL linked, and then I will share, new share with my screen sharing to be able to be looking at exactly the same applet as that you will see on your phone. So let me just give a few seconds. So please access the applet, turn your phone so it is on landscape mode, try and drag up through the GeoGebra bar, the applet, so that you see the little button on the bottom right-hand corner to optimize or to maximize for demonstration purposes the applet. And I'm going to actually demonstrate that as well. And you have the link as well in the chat if you want to use the URL link to the applet as well. So for now, I will, on my side, go with the link to the applet, and then I will do a new share. And this also demonstrates, colleagues, how easy it is to really, over distance, anywhere, anytime in the world, synchronously engage, you know, with this type of GeoGebra applet pedagogy. Here I am, and hopefully, just confirm, please, that you can see the applet as you would probably see it on your phone as well. And you have to click to activate the applet anywhere on the screen, or touch in your case if you have a phone. And can you see I'm dragging down, and here we have our button, which will then optimize. If I click it once more, I have my applet now in demonstration mode. This is the way we will interact, and this is a demonstration then of how the pedagogy using, you know, these customized applets for teaching and learning, particularly mathematics and mathematics problem solving. Now, this particular applet deals with how does one solve a mathematical or scientific problem. Clearly, what is written on the screen is very important to read, and there is also very much generic icons that we have designed. And the slider is a key affordance of these applets for, you know, facilitating the correct and exciting pedagogical strategies that are possible using applets in this way. So as you can see on your phone, and I hope you have turned your phone to be in landscape mode, and you drag the slider by just dragging your, and these buttons were designed big enough so that on the standard smartphone, this would be very smooth and easy to drag through the steps that are part and parcel of, you know, this problem-solving strategy facilitation. And just if all of you can hopefully join me and drag to step number 1. We have started with step number 0. It's all about a very important publication and a person called George Pola, a mathematician, Hungarian. He's called the father of problem solving. And if you're a mathematics teacher and you don't know about Pola, then I think you better have a good look, because it's he has done some fantastic work and contributions in the area of math education, particularly linked to problem solving. And he has really set a set of steps as a general approach in a systematic way to be able to solve problems. And I think all learners offering mathematics, particularly in secondary schools, even post-secondary schools, should be aware of this particular strategy. In fact, all mathematics teachers should read this book, How to Solve It, classic. And if we can just go through the 4 steps, I'm not going to go much into the mathematics and many other aspects of what is built into these applets today. This is more demonstrative to show you what the potential is and to make sure that you can see how easy it is to share and interact with learners over distance, but also to share this for asynchronously participation. Asynchronous, in other words, to share this via WhatsApp or whatever social media, these links, and then with instructions and questions to, and which can form the basis for assignments, and very much learner-centered interaction for engaging the teaching and learning of mathematics over distance. So I'm going to go to the first step of the 4 basic steps. And if you can go with me, first of all, we must understand the problem. So critical in general. And this phase is called the modeling phase. And there are many questions, more questions that we have to think about in terms of understanding the problem first. First of all, language seems to be in some cases a big problem. What are the unknowns, the relevant data? I'm not going to go through all of this, but importantly to model, to make a picture, a diagram, choose the unknowns, labeling, etc., etc. So that's the first step. Without this step, the rest can be a disaster, as we know from the work that learners do. Sometimes they try and solve a problem without even understanding it properly. Second part, or the second step, is critically important also as part of the modeling phase, and that is to devise a plan. You have to have a plan to solve your problem based on your knowledge and based on many other aspects. And these are discussed very briefly here, just as a static statement that can be shared also with learners in general. Let me speed up a bit. The third step of problem solving, you have to carry out the plan, of course, to check. And each step must be carried out correctly and so on. And then the last step, very important, to do reflection and to look back and to really have a look if there's an alternative approach, to reflect on your result and see if there's some generalizations even to this particular problem solving strategy is so important. Then I've also included this, another step here, which is all about, the important aspects of, teachers, the approach to studying and solving problems and, learning mathematics. That is just for reference purposes. So hopefully most of you were able to access the applet and go through the slide, because I just introduced a very key important affordances of a dynamic slider to facilitate problem solving in general. Clearly, it's much more focused than that. So once we have this, behind us, the introduction to the applet itself as an activity, I invite you now to exit the activity and I'm going to go back to my my presentation and just go to the next applet that we would like to do as an activity together. So hopefully most of you were able to access and interact. The next one will be slightly more rich in terms of the pedagogy that is possible to utilize GeoGebra applets in this way. So let me move on. Some of the applet links will be shared in the chat. So if I can just ask my colleagues to share the second link. Now, this is a very, very interesting and exciting concept. It's not part of the CAPS curriculum, but it links very directly to it, in that there's a whole range of practical application across many, many areas of science and technology for that matter. So I invite you to access this applet, which deals with just a demonstration of the concepts Voronoi diagram and the Laney diagram and some applications as a demo. So to show you what is also possible with this new approach for customized GeoGebra applets for phones. So I'm going to go straight to this applet again, and I'm going to do a new share to make sure that we all see this applet at least. For you, the process will be identical. You actually access via the QR code, and maybe I was too quick with the QR code. If there's a need for that, I can go back and give you more time to scan it from the screen, because that's the easiest way to access it. But you can also access it using the link if you want to use your laptop instead to access this particular applet. Once you access the applet, you obviously have to put it in presentation mode. Don't forget, scroll down and activate this full screen mode for demonstrating such applets. Here we have a number of buttons. So important to read what is part of the buttons as well, because it actually gives you then direction in terms of what to look out for, what to do, and the interactivity, the possibilities for interactivity with the applet. First of all, we also have an explanation. What is a Voronoi diagram in mathematics in 2D, on a plane for that matter? It is a division of the plane into a number of regions linked to a set of points that we have on, let's say, the Cartesian plane. And the regions are such, very special, that each region consists of points which is closest to a particular point that was started out with. We call these points seeds, or starting points for the Voronoi cell. So these sub-regions are called Voronoi cells. And the Lonely triangulation, I'm just going to explain that, but you can even select to see what that is all about. So once we have that, so you can switch things on and off. That's important. With applets of this kind, we design buttons, or booleans as they're called, to switch information on and on. Even part of the mathematics can be switched on and off. So here we have a set of points to start out with. And by the way, I want you to immediately drag these points. You have control where you are, and you can place these points anywhere you want to. And that is the fantastic real-time synchronous interactivity possibilities that GeoGebra applets can bring in such a context. By the way, I don't know if you've noticed the slider here, you can even choose your number of points that you would like to work with. These are the so-called Voronoi seed points. And I'm going to use it in two practical applications, demonstrations that are part and parcel of this particular applet. And for every one of these demonstrations, you can select the Voronoi or the Lonely triangulation diagram. So let's just agree together, if we can do this synchronously, to have 4 points. Just take 4 points, make n equal to 4 on your phone or on your device. It could even be the laptop.
Prof,
Yes.
have you done your new sharing? I don't think so.
Sorry about that. It is a cardinal mistake here. Let me do the new sharing. There we go. Does that look better?
Yes, maybe you need to say again where you started.
Just go back.
The new
Right,
share.
sorry colleague, sorry about that. I've got no idea whether I'm on or off. So thanks for that, Arnold. If you come into your applet with your phone, with the diagram, you see this. And clearly you can switch on and off the information that may be needed. And this can also show mathematics information in general. But clearly the slider here, you can actually design and interact with the slider to choose a number of active points you would like to have. Now for a Voronoi diagram, it's all linked to a set of points, where the set of points divide the Cartesian plane or other planes in specific regions called Voronoi cells, where these regions are such that the points are closest possible points to that particular seed point and not any other. So that is what a Voronoi diagram is, to have a diagram of a subdivision of regions of the plane where that may happen. And you can actually choose your number of such points. So I want to ask you if you can drag your slider so that you have 4 points, just to get an introduction here about it. Also, the Lonely triangulation is a triangles between sets of 3 of these points, which is such that any circumcircle of 3 points will not have any other point inside. In other words, it's the biggest circle, through 3 points at a time, where it doesn't contain any other point. A very, very important, triangulation for computer graphics and many other applications which we don't have time to talk about today. So in my case, now let's have only 4 of these Voronoi just as a demonstration. Then I want you to select the Voronoi diagram, and there it is, the Voronoi diagram. Can you see? I have 4 regions of the plane, and I can dynamically, and this is the fantastic thing, you can dynamically with your finger slide your points. I just want to switch off this Voronoi diagram and the Delaunay diagram so that you don't overlap. So there you have your 4 points that you've selected. In fact, you can have more points. And can you see, if I have 5, 6, or 7 points, we have these regions where every point in every region is closest to that particular, seed points, closer than any other seed point that you've used before. And the triangulation, now linking these, every set of 3 of these Voronoi cells with a triangle, and if you look at the circumcircle through these 3 points or any specific set of 3 points, no other point will lie inside. So it's a very special type of triangulation lattice which have huge, possibilities and many applications, important ones for that matter. Right, so let's switch off together our Voronoi and Delaunay triangulation and the set of points. And let's look at our first application that I would like to demonstrate. Very simple, and I'm going to go through it very quickly. For example, if you click or select the airports of South Africa, we see the map of South Africa, and you see your number of points. And by the way, you can create as many points as you want to. Now, I've counted here the airports, the main airports in South Africa. There are 6, 7, 8, 9, 10, 11 of them. So I would like you to drag and slide your applet on your phone to where you have n equal to 11. In other words, you have n of these seed points, the Voronoi seed points. Secondly, just to speed up a bit, we need to just drag these points, and you can do it synchronously on your side with your phone applet on your phone. Just to make sure that each point corresponds geographically to one of these airports in South Africa. Just to give you an idea of a very basic, important application of Voronoi diagrams. Once we have done that, you select the Voronoi diagram, and there we have the Voronoi diagram sponsored by the 11 main airports in South Africa. Now, what does that solve? What problem does it solve? If I'm a pilot and I'm flying from overseas or from one airport to another, and I encounter a problem, clearly, I would like to land at the nearest airport. So can you see? If you, for example, flying and you're somewhere within this Voronoi cell, these are points that are closest, Euclidean distance that is, closest to this particular Voronoi cell or point than any other. I will definitely choose this airport. And so you will then see which is the closest airport to your current flying position should you need to land in the case of an emergency. So with that out of the way, let's just select the airports again to get rid of that picture. And let's look at the second application. And here I would like to more focus on the application of the Delaunay triangle. And we can do many other applications as well. So in this case, if you select the Voronoi diagram, just deselect it, select it again to make it disappear. And you see here I've got some wimpy restaurants. And in this case, I'm just going to place again a cell point linked to each of the restaurants in the Bloemfontein region or anywhere else for that matter. Now let's see, maybe I have too many points here. If I drag my points to each of these wimpy restaurants, and you can do the same on your side, hopefully you'll find it easy to drag and just place them. You see, I've got, it seems to me, one extra point. So I can just put n equal to 10. So I've got also 11 for that matter. And I've covered all my wimpy restaurants. Now, what is the second application? For example, if I look at the Delaunay triangulation here, this, for example, say I want to start a new business, a wimpy. I obviously want this wimpy to be as far as possible from any one of the existing wimpy restaurants as it is shown on the screen. That means I have to look at each set of 3 of these Voronoi cell points look at the circumcircle, and the center of that circumcircle will be the best place. It's furthest away from any of the cell points, including the 3 of which this triangulation then is representative. So that tells you that you can use this particular concept of Voronoi diagram and the learning triangulation very effectively for closest neighborhood type problems, which there's a huge number of them in many areas of science, but also in terms of best possible position to be the furthest away from neighborhoods or neighbors in that context. And that's all I would like to say, just as a demonstration of GeoGebra applets in this context. So I'll invite you again to just exit, and I will go back to my presentation to then just prepare for the next applet that I would like, which is more mathematical and also linked to the CAPS curriculum, because clearly here is an opportunity to demonstratively, interactively, visually, in a rich, creative way, learner-centered, to be able to engage with learners linked to the curriculum or otherwise. I've started with examples outside the curriculum, but this is 100% in the curriculum. So please, while I'm talking, scan this particular applet with your phone, or if my colleagues can just share in the chat again, if you would like to use the link. This is a typical grade 9, 10 problem from the CAPS curriculum, which has very many rich, I think, pedagogical possibilities. And I would like to demonstrate this, and I would like you to do it with me synchronously if possible. So I'm going to go to my GeoGebra applet, and hopefully I won't forget to do the new share now to make sure that everybody sees this applet with me. Arnold, Karin, can you see the particular applet at the moment?
Yes, I can see it, Prof.
Thank you. So click to activate it, drag down. Remember, you're in landscape mode with your phone. Click to optimize, and then we're ready. And this is a problem, a mathematical problem, which is a statement really for demonstration purposes, which says that the area of a triangle is always half the area of some very special rectangle, which has the triangle base and altitude as its side lengths. So, for example, here we have a button again. You can try with me. There you can show the altitude. There's a triangle. And these sliders can be utilized to change the size and the altitude. So I've got a lot of power here to look at many, many different, in fact, infinitely many different cases as part of a dynamic demonstration. Over here, we have the button which says that you have to slide in the demonstration process. And that is always key, but also important to read what is on the screen as part of this applet as well. And we try to make it colorful and the size big enough programmatically, which is quite a challenge, but it's doable. And I think it's great potential in this context. And by the way, there is a button on your phone screen. You may see it as well then, where there are arrows. Whenever there are arrows, you can dynamically drag and control the dimensions of your mathematical object. In this case, it's a triangle. So that makes it even more exciting. By the way, just imagine if learners can do this on their own and answer questions around what they experience visually and dynamically in a very cost-effective way. So that's what really makes us excited. And at any time, you can show the key concept here is altitude, which obviously is part of the CAPS curriculum, very key concept. And if I go to step 2, and I'm going to just try to speed up things a little bit in this context. Step 1. So it says here we have to choose animation. You see there's a pop-up, and many of these applets we have built in animations to demonstrate things as well in a dynamic way. So I would like you to touch this animation button. So if there says animation, touch on your side, or you can click it. You see now what is happening here. This is important, and we can do a lot of questions. We can do a lot of discussion, whether it's in a classroom or out of the classroom, whether it's via Zoom like we have now. It shows that the area stays exactly the same. It doesn't matter. So the critical factors here, of course, in this case is the constant basis and the constant altitude, which determines exclusively the area of such a triangle. And by the way, don't forget you can make the base different dimension as well as the altitude. Okay, so next, to stop and animate, so it actually allows you to interact with this particular mathematical object in a dynamic way. Right, so just deselecting the altitude for now. Let's go to the second step of this demonstration. In fact, it brings up a second slider that you can now interact with. What is the connection between a triangle, the area of a triangle, and that of a parallelogram where you use the same particular side lengths? Dragging this particular slider, and I want you to do it with me, demonstrates very clearly a very innovative way to visualize and see that a parallelogram is just twice in terms of its area the size of a rectangle, as long as the vertical distance between the two relevant parallel sides stays the same, and of course the side length is fixed in this context. Let's do it again. In fact, you can animate it as well if you want to. If you animate this, which is really step 3, I think that I've put in this particular applet, we can see that again, it doesn't depend on, the side lengths or the angles within, etc. It is definitely only linked to the altitude, and then you can select the altitude again. So hopefully you could play around and see interactively with me the power of how this can be, contributing to the understanding of these concepts and some of these results, which are basically linked to the CAPS curriculum for mathematics. I think at grade 8 or 9 or 10 level, somewhere there. So let's just stop the animation again. And you can drag this as well. By the way, you can manually show this as well. And then the last step, that comes back to what we have wanted to do. Remember, we wanted to demonstrate that any triangle, the area is always half the area of a rectangle. A rectangle is a special parallelogram. How does that work? Now we're getting into the mathematics a bit. And can you see this can also be showed very much effectively and visually. Area, of course, is half base times height. Half base times the area of a rectangle. Which one? And there you can just select here to show. In fact, there is a special case which then demonstrates this result, I think, in a very effective and visual way. Hopefully this also showed you there are a number of different affordances of these GeoGebra applets, and it can be combined and designed for a very rich pedagogical approach to not only teach, but to demonstrate things over distance using phones in general. So I'm going to leave this again and go to our last applet, which is slightly more advanced in terms of the level, the cognitive level that it actually represents. So let me then go back to the my PowerPoint slideshow and move to the next problem. Now this is a typical mathematics Olympiad problem that I've chosen to demonstrate dynamically for training purposes or for just stimulating interest amongst those who are talented and interested and wants to really get into problem solving in a creative way. We have heard the concept creativity so much today. So here I'm trying to demonstrate that these GeoGebra applets can be utilized to demonstrate problem solving in a very creative way. And I think it will also be very exciting for learners. Our experience in the center, and we've just started this approach recently, has shown that teachers find this very exciting and to possibilities, and also learners for that matter. But at this stage, we're engaging more the teachers in terms of capacity building around this particular approach to utilize applets linked to phones. So let me go to the applet. Hopefully by now you would have scanned this applet on your phone and you have it. So I'm going to go again on my side using the QR code, and I'm going to do again a new share just to make sure that I don't lose anybody in terms of the facilitation. Scrolling down Remember to touch this button to make it in demonstration mode. And there we go. Now, what do we have here? Here we have quite a very interesting problem, mathematically speaking. And by the way, the solution steps is directly linked with the CAPS mathematics. And this is what we're trying to achieve with our GEP for our webinar series. We have a series of 4. On the 25th of August, there's a third one. It's free. Anybody can join. It's exactly the way we have now with the Zoom facilitation and the sharing of applets. So please, if you're interested, be on the lookout for that. But nevertheless, here we are. Consider two squares that are alongside inscribed in a semicircle. There we have inscribed squares in a semicircle. Is that possible? How many times? There's so many questions around it, but we don't have time to discuss it. But this is typically what one can use to facilitate creative problem solving at the cognitive level 4, which is then linked also to competitions and particularly Olympiads for that matter. So we need to select the animation just to see what this means. You see, there are different ways that I can inscribe two squares in a semicircle. So I'm resetting it. And just note as well that this particular problem is stated for the radius of the semicircle to be r equal to 10, but it can be 8, 9, any other radius. So this is a result which will come out here, which is quite exciting and unexpected. To calculate the sum of the areas. That's what we need to do. This is the problem. What is the sum of the areas of squares in this situation? It doesn't even matter what the radius r is, but say r is equal to 10, and let's stick with that. To understand the problem first is very important. So that's why I've built in some dynamic demonstrations to really see what are we talking about. We're talking about the sum of the area of the blue and the green squares, which are inscribed in this way. And there we have a demonstration again of that. Okay, there are limitations. If this point goes outside the semicircle, it doesn't count anymore. And I'm not going to spend time, but to construct such squares, colleagues, is not simple. It can be done, but it involves a little bit of mathematics as well, which is also linked to the CAPS curriculum, but it's more, I think, for your advanced student. It only makes use of Pythagoras and Euclidean distance and so on. But I've put the -1 step in there. So that's just, if you really want to go into that in discussion. But moving forward, how do we solve this problem? And to show that we can use these GeoGebra applets creatively to solve problems, we need to move forward. By the way, there's even a button here, I don't know if you've noticed, equal square. So that kind of gives a little bit of a clue as well to how we can approach some of this. You can even see the equation of the circle is part of the CAPS curriculum, and so on. So a lot of links to the CAPS curriculum for mathematics in this way. So let me just reset it and go through the steps. Drag the buttons with me. Step 1. You identify the variables. Remember, Polly has forced to understand the problem, identify, make a diagram, etc., etc. So area 1 and area 2, clearly it's s squared plus t squared if the side lengths are respectively s and t, as indicated. All right, so then go to step 2, and this is the critical thing. This is where the creativity comes in, to visualize possibilities. The possibility of solving this problem to find the sum of the areas of the squares in this inscribed way is definitely linked to the dimension or the measure of the diagonals of these squares. And that, of course, will be the square root 2 of s, the square root 2 of t, respectively. And that is directly from the CAPS curriculum, can be explained, nothing about understanding that, okay? And also to notice, and this is the critical fact, that AC is perpendicular to or orthogonal to B. In other words, 45, 45 for the square diagonals, that makes it a 90-degree. And this is the key, because this then allows us to employ Pythagoras theorem or a right triangle construction as indicated. And I'm not going to go into the details, which gives us equation number 1, linking, for example, this distance between A and B. These are the points on the circumference, sponsored by the vertices of these two inscribed squares, the blue and the green one. And equation number 1, if I can get a second equation, then I can probably solve, because remember, I need to solve for S and T to be able to get the areas or the sum of the areas. And that is what I should have put on out as a goal to start out with. Step number 4. This is quite interesting because there's symmetry involved here as well, or transformations of figures. If I flip the semicircle, it becomes a full circle, and the symmetry in this regard still gives me a lot of power in this case to consider what will happen. And clearly there's a center of the circle then, and there are some theorems which you know, are linked to the center of the circle and you know, a point on the circumference and chords, and for that matter, very much caps a line for that matter. Not going to go into the details in this case. So the chord AB subtends 45 degree, AB, or AOB, for example, 90 degrees. And this is important because AOB is a right triangle with the side length Z there, or the segment. And this is at the center. So here we go, you know. We got a triangle, a right triangle linked to the center of the circle. And then it gives us another equation linking the Pythagoras theorem. And with the equation number 1, I'm not going to go into detail, this is just for demonstration. We see, in fact, if we solve here, that the sum of the squares of the areas is 100 square units, which, by the way, in general, will just be the square of the radius. And that's a fantastic, unexpected result for any two inscribed squares which are adjacent in this way. So here we go. So I've really then, you know, demonstrated the affordances for the applet as well as sort of the idea behind it, the problem, so that you can get an idea of how this can be utilized, I think, very effectively to facilitate training for problem solving, even at the level 4 from the taxonomy point of view. So with that, colleagues, I'm going to go out, and hopefully you could participate, access and participate in, you know, the activities linked to these applets, problem solving and otherwise as well. So let me finally just go back to my PowerPoint presentation and just also ask you a great favor, participants. There will be a SurveyMonkey link that will be shared in the chat. And if I can ask my colleague, Karim or Arnold, just to do that. And I would really appreciate if you can give us some feedback. It's a very short survey with key questions about this approach, the pedagogy, its potential, and more important, how easy or difficult you found it to access and utilize these applets in the way as we have suggested. Just to summarize them, summary and conclusion. Customized GeoGebra applets for phones, and it's different to what is out there available. 1.8 million of these applets are available, but normally designed for laptops. So these are very special applets designed for phones with various pedagogical aspects built into it. I think we can really use this, or at least explore the use of it as some key approach to post-COVID challenges in education for classroom delivery, learner-centered lessons and curriculum activities, for access, very affordable access for learner support over distance, which is critical during COVID and post-COVID, I believe, in this country, and to also train, you know, our learners or participants who would like to explore higher level problem solving skills, including preparation for maths and science competitions, which can, by the way, be you know, offered online. We have a special app at the center. We offer you know, mathematics competitions more aligned with the curriculum over a number of rounds via a special app called Mobi to ZA. So there are ways to engage with phones, even to offer competitions, which we unfortunately did not make part of our presentation at this STEMI conference. But what about the preparation for it and the broad access, as was mentioned this morning, even by the Deputy Minister, you know, is very important. And also we can even, and I didn't have chance to, and hopefully we can do this in follow-up workshops if you're interested, but we can also, you know, engage in STEAM activities using GeoGebra applets on phones in the way that I have suggested. So from my side, I really thank you very much. And I'm really looking forward to more engagement linked to the spelling error there, linked to the GeoGebra applets in this way. So that's all from my side. Thank you very much. And there may be some time, I'm not too sure, for discussion or comments. Thank you, Elijah.
Thank you very much, Prof. That was a wonderful presentation, very practical on how to use the GeoGebra applets that to probably improve and enhance the problem-solving skills of our learners. I've seen some comments on the chat, but it's an opportunity to raise them visually in this particular platform. I'm opening up for people that would like to comment or ask questions. You're welcome to just come in and mute yourself and make a comment if you would like to.
Thank you very much. I was interacting with people during Prof's presentation, and I noted questions which Prof should answer or respond to. Tabelo Pizzo had a question, two questions actually. He says, I see create class. I think when we were doing your presentation in GeoGebra, does it mean you can teach with it virtually? And then the second one was, is GeoGebra 0 rated? Those are the first two questions that I have noted. Prof.
Thank you very much, Arnold, to the participant. Thank you for the question. GeoGebra is not 0 rated, it's open source. In other words, it's for free. The platform that you use to host, your access, that has to be 0 rated. So that's not part and parcel of the software and the pedagogy at this stage. But definitely it's open source and for free. And, even in people are encouraged to share it as broadly. Just to also link to the point of whether this can be utilized for teaching online, of course, 100%. Clearly, you need to have some customized, caps-aligned applets in this way. And I may just say that our center has developed a wide range of these applets for grade 10, 11, and 12, and we've got the ability to customize it also on demand, as part of the project. In fact, GeoGebra in this way forms part of our SACE accredited program over 8 short learning programs. It's over a cycle where it's very much part and parcel of that, program. We use a TPAC approach, technology, pedagogy, and content knowledge with GeoGebra is very much part of that, but it focuses on content predominantly, but a big part of it is also to expose our teachers for professional development, to utilize, amongst others, GeoGebra in this way. GeoGebra can be utilized in different ways, but this is just one, I believe, creative way that we can embark on the pedagogy to support teaching and learning of mathematics.
Okay, thank you very much, Prof. I don't know if Tabelo has been answered. If you have not, then you can also ask later. Another question is from Priscilla. She says, can a blind learner read this software with any voice to text software?
Yeah, that is a tricky question. I'm not sure. I don't think, Screens has built-in Braille for that matter. But, so it's quite complex. And I don't know if any other software similar that can do that. So at this point, I have to be brave and say, no, it cannot be done. But, clearly for the handicaps, it's very important. And we also, have made an effort to design some of our applets with the optimal visualization, those who don't see that well, for example, to make sure that the objects and the color and the size and are big enough, even on phone screens, to make it meaningful for those who may be handicapped in that sense. But if people are blind, it's probably not going to be supporting that right now.
Okay, thank you very much. Another question is from Tarmo. I'm sure you're the Tarmo from Sharp. Thanks for the calculator. Tarmo says, is it okay to share this on my next newsletter. I think she's linked to GeoGebra somehow. Over to you, Prof.
Yeah, look, I mean, as I mentioned, whatever I say in the context of GeoGebra is free to share, with anybody. We got much more, of course, but that's normally for part and parcel of training programs. Clearly, just to hand out GeoGebra applets will be very much limited in its impact and value. It's very important to at least go through a series of sessions where you can see the possibilities and the pedagogies linked to each specific applet, and for that, you can always contact the center and we can take it further. But whatever we share today, clearly it can be utilized and shared, with anybody for this purpose.
Thank you very much, Prof. I don't know if there are still any other questions. Let me just check.
Can I ask a question?
I see there's a question about, are there GeoGebra applet training? Yes, the center does that. We do not have a SACE accredited program, but we've got a number of training programs where we actually engage in assisting teachers to become professional practitioners using GeoGebra in general, but particularly to use this applet approach via phones, which is so much powerful and great potential given the cost and the access, the broad access that it can bring.
I see hands from Simon and Steve.
Can I quickly squeeze in? Hi, Prof. How are you?
Hi, so great. I mean, I see a picture on the screen with you without the beard, so, but it's you, right?
I'll put my beard on if I can find it. Sometimes it disappears because my computer is restarting. But
Okay.
Prof, I was wondering, is there a repository of all the CAPS aligned apps and presenters who are compiling these sorts of apps? Is there a repository or collection where teachers can then access these sorts of apps that they can then tie in with the curriculum and fit it with the work that they are doing? Because, I mean, it would be so nice if I took the entire curriculum and then said, oh, it would be so nice if there was a GeoGebra app for the turning point and for differentiation to find the curve, and all of a sudden I can go into this little library and I can pick and choose the ones that work for me. Does such a library exist? And if not, why not?
Good question, Steve, and you're 100% aligned with my thinking and my vision. By the way, we started to develop these applets, I myself, doing it from the beginning of the year. So it's in work in progress, and clearly there's a partial library already, and that will be shared as soon as possible if we have completed that within, probably by the end of the year already, because we've tested this, and it's not just for sharing. Of course, it's all about the pedagogy and the strategy and empowering teachers to have the confidence to use this, but not to only use it, for them to share it with their learners via, the social media and so on. This is the idea. So there's a bigger picture, 100% aligned with you. Why it doesn't exist, is because it's quite technical and highly specialized to develop them. But I will share info. If they stay in touch with the center, we'll definitely, as soon as we have sets like for grade 12, grade 11 available, we will share it.
I mean, is there a community? Sorry, I just wanted to follow up. Is there a community of GeoGebra teachers who meet and want to store all of them in a library?
Yeah. Unfortunately, not at the moment. We got a GeoGebra Institute linked to my center since 10 years ago, and we're reviving that. And the whole GeoGebra for innovative practice is our kind of approach. And anybody who would like to join, I would like to set up such, because not everybody, it's all about engagement and community of practice. And this is what this conference is so wonderful about, to bring people together we got a core group of my colleagues, but very, limited, but we want to share and get more ideas and more. We got the technical know-how otherwise. So very much so. We can use the GeoGebra Institute at the center, the Government Banking Master Center, as a basis to share and engage, and even add, I haven't demonstrated, but we can add the STEAM activity applets as well. It's not only for curriculum, but it's also for problem solving in general, and then the STEAM. And so it really ties in with what you have really, so eloquently promoted earlier today as well.
Okay, thank you, Prof. I think there was a question along those lines, I think on the chat as well, whether you have applets for primary schools. Perhaps I could add to the question by rephrasing and asking how much of the CAPS curriculum have you covered in your development of the CAPS across grades, which may then include even primary schools?
Let me just mention there is an old series which was developed for laptops. We went through many years of engaging teachers with our programs for professional development in using GeoGebra on laptops. So there's a difference between an applet for laptop use exclusively, to demonstrate and teach, and the ones currently for the phone screens, which are much smaller and hugely more demanding in terms of how you're designing. So there's an old series that we can share, and I'll probably share it with you what we have developed already, plus a little PDF document that goes with that. But the completion of the grade 10, 11, and 12, grade 12 we've completed, but it's never really complete because you always improve. But there is a basic set that's complete, and grade 11 is halfway through, and grade 10 will sort of be a subsequent series. But that will hopefully be done before the end of the year, and that we can share as well.
Okay, thank you very much. And Simon, Albin, do you still want to come in? I see your hand.
Good afternoon, Prof. Good afternoon, everybody.
Good afternoon, Simon.
I'm from Namibia, and I'm glad to join the team. I'm a student in realistic mathematics education, and I'm researching on geometry, and I've chosen GeoGebra Sketchpad. I just want to Prof to help me whether I can still have the same exploration using GeoGebra Sketchpad. Thank you.
Simon, and I'm not going to, it's very subjective, but, to me, there's some non-negotiables in this context, especially if you're aiming for a systematic approach, which is innovative for scale. And the open source nature of GeoGebra makes it. I'm not too sure exactly what the latest status is of GeoGebra Sketchpad. I know that as well from, historically. But I do think you can do similar things, yes, but it obviously will be very much technically specialized in the context of that particular software, which I cannot really talk to.
Okay, thank you very much, Prof, and thank you very much, everyone who attended this session.